In this video, I am going to find the absolute extrema, the absolute maximum or minima for this function f of x equals x plus 4 over x on the domain 0 to positive infinity. So to do this, I'm going to find the first derivative, f prime of x equals 1 minus 4 over x squared. I'm going to find the critical numbers, so that I set the first derivative to 0. 0 equals 1 minus 4 over x squared. 4 over x squared equals 1. 4 equals x squared, so x equals plus or minus 2. But on our domain, x is only positive, so we're only interested in x equals 2. That's a critical number. The first derivative is not defined at 0. That is another critical number, but again, it's not in the domain, so we don't care. I am going to draw a number line. I could do this in two ways. I could draw a number line for the first derivative to see when it is increasing or decreasing, or alternatively, I could look at the second derivative when at our critical numbers, but I'm going to use the number line version for this particular problem. So we know the first derivative is 0 at 2. There are no other zeros, so it's either going to be positive or negative between 0 and 2. We can test a number, for example, 1. 1 minus 4 over 1 squared is negative 3, so the first derivative is negative in this region. And then if we test a positive number bigger than 2, let's say 1,000, then 1 minus 4 divided by 1,000 squared, that's 1 minus 4 millionths, and that's going to be positive, approximately 1. So this is our function. This is our first derivative. So we know the function itself is decreasing between 0 and 2 and increasing between 2 and infinity. So first off, we know from the first derivative test that this is a local minimum when x equals 2. But actually, because the function's decreasing between 0 and 2 and then increasing above 2, it must be an absolute minimum at x equals 2. And the absolute minimum is f of 2, which is 2 plus 4 over 2, or 4. Now we have to ask ourselves the question, is there an absolute maximum? And so we have to look at our region and we say to ourselves, when x is very, very close to 0, then our function is x plus 4 over x, which gets very, very big. So I could write this as the limit as x goes to 0 from the right-hand side of x plus 4 over x. 4 over 0 or 4 over something very close to 0 is going to be very large. So that's equal to positive infinity. So it looks like this function can take any value between the minimum 4 and positive infinity, which means there's no absolute max.